Hey, welcome back. Today I'm going to have a look at this Pyle marine amplifier. It's a PLMRA400 and yeah, it's marine grade waterproof. I don't believe one word of that crap because there's no seals here at all. There's no nothing. It's just paint, white paint. Anyways, oh, let's have a look at this. And the fuse is blown. I don't know if you can see that. But let's take it apart. It boasts that it's got 400 watts into 4 channels. And if you look at the inputs, we got 4 RCA inputs, and then we got 4 high-level inputs. The right and left on this side, right and left on this side, and then there's level controls, which is nice features to have. On the outside it's got plus minus 12 volts, remote kick on fuse, and then you got your 1, 2, 3, 4 channel outputs. So yeah, it's pretty simple. And just because it has white paint doesn't mean you can't use it in your car. This one took a little bit of a hit. It's pretty beat up. The extrusion on this side's all twisted and bent. Maybe it is right. No, look at, oh, look at this. And a little bit of, oh, that's fuzz, it's paper. Oh, there's their waterproofing. There's a foam gasket on this side, a foam gasket on that side. So there's your waterproofing. This thing, what's rattling in here? Oh, that's what's left of the cap. So the cap exploded, it shot straight up, and the top is all mashed in, mushroomed, because it hit so hard. And this is a 47 mic at 16 volts, I believe. Yeah, that capacitor there. Oh, well, look at the brand where this Chongx. I did a video on these capacitors. Okay, so we got a blown capacitor, blown fuse. Oh, wait a second. This board's all cracked. It took a hit somehow. Maybe it was dropped. I got cracks here. And you can see these cracks. There's a crack here, crack here. The cracks will be easy to fix. I just gotta do a little bit of soldering. It shouldn't be that bad. So this thing's run off of 2 chips, 2 power amp chips. So I guess they're stereo, 50 or 100 watts each side. So let's get this board out and have a look at the underside. Well, that's the end of that. I was pulling on the knobs and I busted a pot. What kind of chip are we running here? It doesn't say. I got a screw here. Okay, slide it out. Yeah, it's got a crack here. You can see it. It doesn't look very severe. I could fix that. It's surprising that these tiny little chips can output 200 watts. They're just small. Look how small they are. And there's no part number on them that I can see. Oh yeah, there it is. It's a S. What is it? S1540 SAN. I can't read the manufacturer's name. I've never seen that. Let me look at this one. S1540 SAN. Side chip. That's the manufacturer. I've never heard of that before. S1540. Let me go look that up. Okay, I looked for these chips online, and I can't find any mention of it whatsoever. I couldn't even find the name of that company. So this is pretty obscure Chinese junk. But I did find the owner's manual for the amplifier, and here's the specs. It claims output power at 14.4 volts DC, 1 kilohertz. We have 100 watts times 4 max. Frequency response, impedance, blah blah blah. Power supply voltage, yeah, typically it's 14.4 negative ground, and impedance 48 ohms. Maximum current draw, here is interesting, 10 amps. So let's say we have 14.4 volts at 10 amps. That's a maximum of 144 watts. So I'm not seeing how they can get 400 watts out of this thing when the maximum current draws at 10 amps. Even if the fuse is rated at 20 amps, so if it draws up to 20 amps, that is only 288 watts at maximum current draw. So how they claim 400 watts is beyond me. Anyways, what I think I might do is, I got a busted pot on this side now, but this side should still work. Let's see if we can get this thing running, and then we can do some bench testing on it just to see how bad it is. First thing to do is change that cap, I guess. Clean up this board a bit. So let me get some caps. Yeah, I found a cap here. Where is it? 47 microfarad, 16. I don't even want to put a brand new cap in this thing because I know I'm just going to end up throwing it away after anyway. So let's see here. And my iron's off. Would you believe it? Looks like I might have a little burned resistor here too. Let's see. I hope it's not burnt. I don't know its value. It's open. So we might have to figure out what that value is. Oh, what's this? 150 ohms. That's kind of what the color bars look like. Can't really see them though because they're all dark. But it does look like brown, green, brown. So that might be okay. 150 ohms. You can't see that, can you? It's all glare. There. Yeah, I think that's okay, that cap, or that resistor. Poof. So let's see, I'm gonna have, if I do get it going, I'm gonna want to do a power test. And I think, well, I know my bench supplies, they max out at 5 amps, so I don't know what that's gonna do for us, but we're gonna try it anyway. So we got our new cap in there. Now let's do a little bit of continuity testing here because this board is broken. From plus 12 volts, it should go there, that's right, okay. And we need a fuse. Fuse is good. Through the choke. Choke is good. Plus 12 volts to that chip. Over here. Plus 12 volts to that chip. Ground. So I should, oh yeah, okay. Jumps across here. Okay, so we got plus 12 volts and ground to both chips. Let's check speakers on this side. It's working. Working. Okay. Jumps across to here. Working. Working. So far, all of this side's all working on the speaker and the power. We've got a break there. This one's not working. Got a break under here. Right there. Okay. That one's working. That one's working. Okay. Now our break is right here. We have a huge crack in the board, and I suspect this is probably the power on switching or whatever. Where is the remote sense? Okay, so remote sense. Yeah, and then it comes under here. And it goes through a diode. So diode's good. But I'm going to have to fix this. So what I'm going to do is fast and dirty. We're just going to bridge the crack with some solder. And we're going to do that wherever the crack is. And it goes all the way from, I don't know if you can see that crack, can you? You see that crack? It reflects the board. A huge crack here. That's cracked, but that solder is holding. This is cracked right here, this trace. And then I think it ends here somewhere. Oh, we have this one. Okay, the crack continues across this one, this one, this one, and ends here. So I'll do these. Solder these up. Now, if I was doing an actual repair on this, I'd probably use jumpers. I wouldn't rely on the solder itself because it's just going to crack again under thermal stress, vibration. Some better cleaning here. Some flux. Like I said, this is quick and dirty. Okay, let's check some of these. been using this meter for 20 years, you think you know how to use it. Okay. It's all working. That's working. Good. Good. And these are working now. Yep. Okay, I think we're done. Let's put some power to it and see what it does. Okay, I got 13.5 volts here. And we got a dead short somewhere. There's this little diode here, and I don't know if that is good. It is across the positive negative. Let's just check this right now. No, it's dead short. I'm going to pull that diode out. Come on. My leads aren't working today for some reason. So that diode's out. And it's not a dead short anymore. What's going on here with this thing? Yeah, that diode is dead. Let's put another diode in there. But for the sake of testing, we don't need it in there at all. Okay, so let's power it up again. There we go. We got 0 voltage draw. Or sorry, 0 current draw. Now if I jumper the remote start here, a piece of wire, the amp should come alive. Okay, now I'm drawing 220 milliamps. The amp's alive. I think it's going to work. Let's put it back in the heat sinks, and then we'll do a test on it. I think we're going to check out this side only because this side's got the broken pot. But I'll just tighten this down just so it doesn't get warm. Both chips are good, why not? Okay, I got it fed with signal generator, the input. I got a speaker dummy load hooked up. Okay, we got it all wired up. I got a 1 volt signal coming in and 1000 hertz. Got 2 dummy loads, 8 ohms coming out. Power's hooked up. I just got to turn the amp on. It comes on slowly. I'm drawing 260 milliamps right now. I'm getting nothing on the scope. Let's turn up the volume. No. So when I turn this down, this input pot, it drops to 260 milliamps. When I turn it up, it goes up to about 310. And I got dead silence on the outputs. Stone cold. The LED's on, the amp's on, it's drawing current, and there's zero output. Okay, just to give you a little update here on what's going on. I couldn't get any signal from the inputs to the power chips, and I did some troubleshooting and stuff. This potentiometer, I followed some of these lines, and I wasn't getting any continuity between this pin and this joint, and somewhere along this trace there's a crack, but I can't see it, but there's no continuity. Another thing is there's some cracked solder joints on this chip, and this chip here has 1, 2, 3, 4 lifted pads from the board, so I have to check continuity in all these lines just to make sure, because I think, oh, these are all lifted too, they're moving. I don't know if you can see that. They're moving, so there might not be connection there on a few of these. So what I'm going to do is make sure all of these have continuity and connection, and we're going to continue pushing forward here, so stay tuned. So I got the solder mask scraped off here. I'm just going to scab some solder on here just to make the connection and bridge the gap. The amplifier took a big hit, that's why the board's cracked, and I suspect, well, these chips were bolted to the heatsink, and with the impact it busted all the solder pads free of the board, and this is why we're doing this. That's why it didn't work initially when I powered it up. Just jump across here with some, and there we go. And I believe I have a ground here or something. And I'm kind of curious to get this going to see how it performs. These unknown Chinese chips. Okay, I think I got them all. I'm going to inspect them again with my lens. What threw me for a loop was I was feeding input into these two, right and left, and going into this potentiometer. This is a quad op amp, so it has 4 op amps in this package. There's 2 on this side, 2 on this side, and the signal comes in here, goes through the pot, goes into an op amp or 2. I'm not sure about the configuration of that. It's got something to do with this too. This is your high level input too. And then it goes up here to these blocking capacitors and these resistors. Now you would assume signal coming in this side, pots on this side, this would be your power chip, but it's not. They do a reverse and it shoots over here. So that's why I couldn't get it working. I was feeding a signal in here, and this is the chip I'm supposed to be working on, and this is the one that had all the breaks, so it's pretty obvious why it wasn't working. So I think we got, oh, I still have to do something with this trace here that's got no continuity. I can't figure out why. I think it's cracked here, but I can't see anything. Let's just solder on some more scabs here. This isn't normally how I repair things. I would just put a wire in here, a bodge wire, but this one, resolder this one. Now I should have continuity now from this there, and this one. Okay, good. Good. From here to here. Okay, everything seems good. I'm going to put it back together and try it again. Okay, we got it back together. Got it all hooked up to my bench power supply. Got an input from the signal generator, feeding it 1000 hertz at half a volt. Got it hooked up to an 8 ohm dummy load. Got both channels scoped, and I got one channel to an RMS voltmeter to measure power output. Let's fire this beast up and see if it'll work. Oh, one thing I've done is I removed this chip from this side completely, because this is the channel with a broken potentiometer, so this channel is going to be dead. So I just removed the chip just so it wouldn't throw off our precision test here. So let's power this thing up, and it doesn't want to start. Something is with, there we go. If I disconnect my scope grounds, it starts up, but if they're connected for whatever reason, it senses short maybe, I don't know, and it doesn't want to start up. So, but we got 140 milliamps on the input right now at 13.5 volts, so the power amp is alive and working. Let's start feeding it some signal. And we're getting an output on, let's hook up both channels. Getting an output on the dummy load. Turn it up. Here, let me spin the camera around so you can watch the scope. So right now we got 3.1 volts RMS on the outputs, and I'm drawing 1.77 amps on the power supply. Let's turn this up some more. Oh, we're clipping already. What's going on here? This can't be right. So if I turn this up to clipping, I got 3.78 volts RMS. Let's feed it a higher signal. No, it does not want to go past that. 3.7 volts RMS output. And I'm drawing 2.08 amps on the power supply. Let's turn up the voltage a little bit. I'll put it at 14.4. I'm going to confirm that at the terminals. .3 at the terminals. So we should be able to get a little more legs out of this. Turn this up. And it's clipping at 4.2 volts RMS output. That's not 400 watts, or even 100 watts per channel. A bit of a lie there, I think. Here's a distortion point, and I'm getting 4.03 volts RMS. This side of the heatsink's just starting to barely warm up. What I'm going to do is let this run for about half an hour and see what it does. Okay, just a correction here. I had some values I just mentioned on the previous clip of the video that were incorrect. What happened was the negative lead of my voltmeter came undone and I was getting wrong readings. So now I'm getting full output just to drive it to clipping. I'm getting 9.6 volts RMS on the output, just to make sure that's clear. And that's a far cry better than what I was calculating before, which was incorrect. So this has been running for maybe 20 minutes now. This is barely warm. My heatsink is getting quite a bit warmer. It's starting to get hot. And I'm just going to let this cook for a while, and then we'll do maybe a 4 ohm load test, see how that goes, and then we'll try a frequency response. Okay, so we had this on running for about an hour now at full output, and you know, this heatsink side of the heatsink here is barely warm. This side's cool. My 8 ohm dummy loads is actually a lot warmer than the heatsink itself. And I'm getting 9.57 volts on RMS on the output. So let's do a frequency response test on one of the channels and see how good that is. So let me hook up the scope again. I'm having problems with the scope monitoring both channels because of the ground leads. They interact with the chip, and the chip doesn't like that ground loop, so I just disconnect it. But let's go on the scope here and we'll monitor one channel. I'm driving both channels to clipping, but I'm only monitoring one. So let's try doing frequency response and see how high this goes. Here, actually, let's shut off channel 2. And let's channel 1. You can see it there, it's clipping. Right about there. Okay, let's start jacking it up frequency. Starting to drop right around there, 23 kilohertz. That's 50 kilohertz. It's gone down quite a bit. Let's keep bringing back channel 2 for me. I don't want channel 2. Frequency response drops, but I can still jack up the volume. Okay, let's keep going. Yeah, it's dropping quite a bit now. 62 kilohertz. 90 kilohertz. Lost our sine wave. Let's turn up the volume. 2.5 volts. We're clipping on the bottom. Right about there is maximum. Okay, hooked up 4 ohm load, we're on, and we're pumping in a signal. Let's see if we can get... There's clipping. I'm getting 8.95 volts RMS on a 4 ohm load. Just going to let this cook for a while too to see how it handles the extra current, and just let this cook for a while. I'm feeding it with 14.8 volts approximately DC, and it's drawing 2.25 amps of current. In case you're wondering how I desolder a chip the fast easy way, it's just like this. You don't get too much heat, you don't want to burn the board, you just want to heat up the solder. Out she comes. And you got the chip. And well, the pads were already ripped off the board to begin with, so that's why I bodged them. But yeah, if you do it careful with your heat, you don't burn the board, and the solder melts, and off comes your piece. It's very quick and easy. I could even do this chip too if you want. I like to have a pair of needle nose pliers to hold it from below. I grab the ends of the chip just like this, right? A pair of needle nose. Grab it fairly firmly too, and just heat the pins. Not too fast. And out she comes. That's all there is to it. Okay, so it's been running for about half an hour now. The side's getting quite a bit warmer than it was when I was pushing an 8 ohm load. But I'm only using half the chip on a 4 ohm load, so if I had another 4 ohm load I'd hook it up, but who cares. But anyways, this thing's junk. It's got junk capacitors in it. The printed circuit board, it's junk. It cracked on me in several spots. There's a crack here, there's a crack up here, so it's not a fiberglass board. Fiberglass won't crack like that, and this is just a cheap Chinese amplifier dressed up as something nice. I'm gonna scrap this. A good chunk of aluminum here, extrusion. Throw that in my scrap aluminum pile and get some money for it. It's got a few pounds, or a pound at least. And I don't know. Maybe I'll save the chips in case I come across another power amp that needs help. But definitely not 400 watts. Definitely not. I don't know how they get away with making those kind of claims, but they do, and I don't know. I don't think that's right. But anyways, thanks for watching.